be on. And this is yet another thing that I would never do if I were teaching down at URI. It would be,
A review.
no, there would be, here is the review. Look at your notes. Any questions? No? Okay, so we're done with the review. Tomorrow's the exam, or whenever the exam is. Okay? So first topic right here. Well, you tell me, what are the major topics?
The integumentary system.
Integumentary system.
Bone tissue and structure.
Hold on a second. So now, the integumentary system is going to be about 25 questions. What's another topic?
Bone tissue and structure.
So osseous tissue. That'll be 30 questions. And then what?
And then, now it's bones.
The bones. And so how did I divide the skeletal system up?
You did
The skull
appendicular
and then
skeleton,
the
axial,
vertebrae.
and pectoral girdle, and pelvic girdle.
So there's the axial skeleton. And what did I say how did I divide the axial skeleton up?
First part was skull, and then the second part was.
So the skull and what else?
Vertebrae. The skull, the vertebrae, and then the sacrum.
Wait a minute.
Coccyx.
So where is the sacrum? What is the sacrum a part of?
Oh, the coccyx.
Right? Wait a minute. What are the sacrum and the coccyx a part of? The sacrum and the coccyx are part of the
Oh, the
vertebrae.
vertebrae, yeah.
So there's the skull and the vertebrae, ribs, and sternum. That's going to be about 15 questions each.
Oh my.
So not very much.
Skull, vertebrae, and ribs and sternum.
Then there's the appendicular. What major topics did I say there?
The pelvic girdle.
And the
pectoral girdle.
pectoral girdle. Right? The total is 120 questions.
Oy.
No, what am I saying?
Wait,
It's
120?
never 120.
Oh, it's like 115.
115.
That's not too bad.
I think the other exam it was more. I think if I'm not.
Okay? And I will save this up on the Brightspace page. So the axial skeleton will be about a quarter of the questions. The appendicular will be about a quarter of the questions, about a little bit more. Osseous tissue and the integument. Now, what should you study for the osseous and the integument? What things should you go back to?
Everything.
Wait, 115, the slides.
What did we do earlier in the week?
There was the 2 layers
What
of the
did we do
skin.
on Monday?
Chapter 5. No, wait.
The bone.
Oh, we
The
have to
skins,
go, like,
the different layers of skins.
before entering the slides.
So you were evaluated on Monday. How so?
Chapter 5 and 6.
What
The
In
quiz.
what capacity? What was that? There was a separate quiz? And I think that you should be able to go back to those quiz 5 questions and revisit them. If you got them right, that's great. If you got them wrong, you should be able to figure out what's wrong. What?
I didn't like that.
You didn't?
No, I feel like it was a little different from what I studied.
Okay, so don't do that again. All right? Don't study the way you studied. Study different stuff for quiz 5.
Bless you.
Thank you.
The questions on quiz 5 will be used again on the exam, right? Not all of them in its entirety, but they definitely will be. I don't think that there's anything that I'm holding back for quiz 5 that I was holding back in terms of topics from quiz 5. So in other words, everything that I had from the integument and the osseous tissue will be on the exam. There'll be lots of diagrams and labeling. And then there'll also be questions based on the text-based questions. So text-based questions would be going medial to lateral, what bone is, what is the correct list? If it's carpals, if it's tarsals, if it's going superior to inferior and you're doing vertebrae, right? Inferior to superior and you're talking about vertebrae. Remember the terms proximal and distal are relevant for the arms and legs, not relevant for the torso. Right? Remember that vocabulary from quiz 2. Is there anything else that we talked about that I missed for the exam? Okay. Now, in terms of the exam, where the hell is it? So in terms of chapter 6, I'm not going to go over chapter 5 right now. I'm going to go over just chapter 6 here. So these are notes that I've already posted here. Here's this vocabulary here, beginning with osteo and osseous, the prefixes and suffixes. Quiz 2, vocabulary. If you didn't do well in quiz 2, you should go back to those vocabulary terms because we're definitely going to be asking them. I mentioned the 6 types of bones. Right, so let me see something here. This looks like so long bones, short bones, irregular, flat, sesamoid, and wormian bone. You should be able to recognize the specific examples of each of those and where they are and where they're not. Especially the sesamoid bone, wormian bones, where are the only place that you can find wormian bones are between 2 cranial bones. The specific example of the sesamoid bone, I won't, when I talk about short bones, what the hell did I do there? What is this? I don't know how I did that. In terms of short bones, I won't ask you to distinguish, is this a short bone or a long bone? Right? So the long bones will be very obvious. Short bones, I wouldn't ask you to say a carpal versus a metacarpal. Metacarpal, a short bone versus a long bone. I don't really care about that, right? They're going to be very, very long bones or short bones. Remember, too, the vocabulary, we talked about the projections, holes, foramen, foramina, fissures, and canals. Depressions, processes, condyles, epicondyles, tuberosities, and rami, or ramus, individual ramus. 2 different types of bone in terms of bone strength. There's spongy bone and compact bone. The spongy bone, they're essentially, they're very, very similar in terms of the orientation and building of them. The distinction there is spongy bone and trabeculae, and those trabeculae are these long processes that are not continuous, and because they're not continuous, they make spaces, and those spaces then appear to be spongy. The spaces that are found in the spongy bone is also called red marrow. Right? Compact bone is where the bone is continuous. So there's no space between the bone. There's no significant amount of space. There's definitely spaces. 2 spaces in particular are, well, we'll talk about what those are in a second. In terms of the compact bone, then the osteon is the functional unit of the compact bone, right? Here's my wonderful drawing of a femur. And we talk about the epiphyseal plates versus the diaphysis. There's the proximal versus the distal epiphyses. There's the epiphyseal plate versus the epiphyseal line. The plate is actively growing and adding hyaline cartilage. The line is no longer growing and it's ossified. There's red marrow and yellow marrow. The yellow marrow will be found in the diaphysis, and I'll mention what that is in a second. The red marrow will be found in each of the epiphyses, either the proximal or the distal epiphysis. So the red marrow tends to be found in the spongy bone, rather, the spaces between the trabeculae. And the red marrow is really for hematopoiesis, or blood cell production. That's not to say that blood cell production doesn't happen in the diaphysis, but the majority of it happens in the epiphyses. If you're going to talk about the diaphysis of the bone, the shaft of the bone, there's a major hole in that bone, that's called the medullary cavity. So the lining of the medullary cavity, there'll be a little bit of spongy bone, and then that's going to be layered by the endosteum. The endosteum is, again, superficial to the medullary cavity, superficial to the entire bone is the periosteum. The periosteum, then we'll talk about those next Wednesday. We're going to talk about the periosteum being continuous with connective tissue, that is to say ligaments and tendons and joints and articulations. And then the following Monday, I'll do a big drawing using this iPad, and that iPad's going to be, I'm going to draw this bone right here, and then I'm going to say, let's just say right about there where my red marker is, I'm going to put a muscle attachment, and then that whole thing, we're going to do a big long muscle attachment and what the muscle looks like. We're going to start at the macroscopic of the muscle, and we're going to go very detailed. The periosteum, though, is continuous. It's connective tissue, and it's got two layers, a fibrous layer and a cellular layer. The periosteum particularly is not worried about osteocytes or osteo anything, right? The periosteum is particularly worried about with cartilage and collagen, right? So it's going to be in fibrocartilage, fibrocytes, fibroblasts. Those are the ones that are going to be interested in the periosteum, and then those will then go distally from there and surround muscles. In terms of the osteon itself, the osteon is a series of layers, and that central hole right there is called the central canal. I mentioned I said there's no space in the compact bone, except two areas, major areas here. There's the central canal, and then perpendicular to that is called the perforated canal. The central canals run parallel to the length of the bone. The central canals run parallel to the medullary cavities, the hole in the major cavity. As you go away from the central canal, you go superficial from there, right? You go to lamellae. So the lamellae are individual layers here. So in this drawing right here, I have 1, 2, 3 sets of lamellae, and one of them is indicated by that with that red parentheses marker. So the lamellae are successive layers moving away from the central canal. Then those little lines there that are associated with each of the lamellae, those little lines are the canaliculi. And those canaliculi allow for the cells in the bone that's maintaining the bone tissue, the cells in the bone to survive. Where are the cells in the bone? These little football-shaped things. Those little football-shaped things are called lacunae, and residing inside the lacunae, because we're talking about bone, they're osteocytes. If we're talking about cartilage, there would be chondrocytes. If we're talking about individual fibers, there might be fibrocytes, right?
So this is the lacunae, this would be a membrane?
No, it's a space. It's like a room. So when the osteoblast is laying down bone, right? It starts laying it down in this area, then it goes into it makes a 360-degree circle, and it makes its own cavity. And so once it does that, there's these little perforating holes called canaliculi that allow for fluid to get in, plasma to get in, and nutrients to get into the cell. so once it does that, then it's called an osteocyte instead of an osteoblast. So lacunae is a general term. Yeah.
The way I remember, how do you say it? Lacune?
The space is lacunae.
Lacune.
Mhm.
So what is lacune?
That's the same thing.
Oh, okay.
I think this is this spell. I don't know. We love this.
So Lacunae is how you spell lacunae.
Oh,
But
yeah.
sometimes the E is left out for
But-
some reason.
So if it's lacunae with the E is singular, if it's plural, it's lacuna, I think.
Oh, yeah. The way I remember what that is because in Spanish, lacuna means the crib. So it's like kind of like a crib for osteocytes.
Oh, okay.
Yeah.
See, I knew that. I just didn't want to tell you that.
Oh, really?
Yeah, I know.
Laguna.
I speak Spanish really well.
You know, like,
Oh.
See, like you guys didn't understand what I was saying
It's like the
before.
space
Osteocytes
where you
in
go in.
Spanish.
So,
What?
just
What
what
is it? Osteocyte in Spanish.
No, say it now. Although I have had, on occasion, a number of years ago, I had two students arguing in Spanish about math homework.
Oh.
One girl said, "Where's my math homework? You have it." The other girl said, "No, I don't."
Oh.
And I interrupted and I said, "Geraldine, will you just open up your bag and look for her math homework?" And both girls looked at me like, "Wait, you know what we're saying?" And I was like, "Yeah, why?" And so I said, "Marshall, let her go check her bag," right? So Marshall and Geraldine are arguing. And so they look at, sure enough, Geraldine had her homework. So she gives it to her.
Huh.
And then they both said to me, "That was weird, because old white guys shouldn't be speaking Spanish." and she goes to me, "You better stop, that's my language." And I said, "What do you mean that's your language?" So anyway, that was a long time ago. So
Damn.
once in a while I can understand it, but the problem I have is that once I get a vocabulary word that I don't understand, I get stuck on that vocabulary word and the conversation keeps going, and then I get lost.
You say no sé nada.
Yeah, right? All right, so let's get back to this. In terms of, so that there's individual osteons that run the parallel of the length of the bone. Then there's also, and those are surrounded by lamellae, right? Those are the layers. So when they're not overlapping, those lamellae are called concentric. And then when the bone starts to get finished, in other words, the entire diaphysis of the bone begins to get finalized, particularly by the periosteum, then we have circumferential lamellae. Those circumferential lamellae are ones that go all the way around the bone, and those are superficial superficial to the concentric lamellae. They're adjacent to the periosteum. Okay, so they're
Can you scroll up really fast? No,
can I what?
scroll up to see the picture.
So what I have here is these are concentric lamellae. So a concentric ring is ones that don't overlap. So these are concentric lamellae, and that's what a concentric lamellae is in a single osteon.
Wait, what? I don't understand.
Let me see if I can get rid of this.
What do you mean that it overlaps?
So these are concentric lamellae and they don't overlap. Right? So they are laid down by these osteoblasts that then turn into osteocytes. These lamellae, then there's a whole bunch of osteons that are built that are parallel to the length of the bone. So there's a circle here and a circle there and a circle, and they go all around the medullary cavity. Then superficial to them are a series of circumferential lamellae. And those lamellae are around the periphery of the bone.
They're only on the outside.
They're only on the outside. That's what the periphery, that's what I mean by periphery. So these circumferential lamellae are superficial to the concentric lamellae. The circumferential lamellae are adjacent to the periosteum. And then superficial to these superficial lamellae is the periosteum itself. And then that's the end of the bone. So basically the periosteum is a plastic bag around the bone. And then the first layer of lamellae are circumferential lamellae, and then deep to them are the concentric lamellae. The concentric lamellae are the much more abundant.
How come we don't hear about the, was it
Interstitial mammalian, those aren't really funded. And I'm choosing
So
out
you're
limits.
saying the spongy bone will overlap?
So the spongy bone is going to be adjacent to spaces and either in the epiphysis, the distal or the proximal epiphyses, and then it'll be adjacent to the medullary cavity. So the spongy bone might be, if this is right next to the medullary cavity, the spongy bone might be right here. But it's going to serve a different purpose. That term spongy bone doesn't mean super weak, it just means weaker than compact bone.
Wait, is this only for compact bone?
This drawing right here and this discussion right here is only for compact bone, yes. I think that's, yeah. Let's see.
What are you doing?
So I posted this already. Right? Is there any reason to talk about the integumentary system? So the integumentary system, well, wait a minute here, before I forget, what's other things I haven't talked about in the notes behind me? In terms of chapter 6.
Bone shapes.
Cancer?
Arthritis stuff or cancer?
Well, so there's arthritis, things that go wrong. There's cancer is particularly relevant in the skin because it's much more prevalent. There is bone cancer. It's called osteosarcoma. That's not as frequent. But let's talk about other things that we're talking about in the bones here, and particularly ossification. Ossification here, we have two different types. And so let me see if I can get over there. Well, I'm not-
Yeah.
And then different stages.
Well, no, this is the actual.
Guys, are you ready for SATs next week? I mean, no, not next week.
2 weeks?
In 2 weeks, yeah.
No.
I just want it to be over already.
I just want to go home.
What?
So when you're talking about ossification, there's intramembranous and there's endochondral. The first term, intramembranous, what does intra mean?
Mm-hmm.
Inside what? Inside a membrane. What possible membrane have I mentioned that this process might be a part of? Talked about something being superficial on a bone. The periosteum, and what's the other one? So the endosteum, right? So those are the sort of cousins to the membranes that we're talking about here. When you're talking about intramembranous ossification, you're talking about largely flat bones, irregular shaped bones. Right. The end result of intramembranous ossification is a combination of compact bone and spongy bone. It is exactly what we just talked about. Endochondral ossification. What does endo mean? Inside chondral. What is chondral? What kind of cartilage?
Hyaline.
Hyaline cartilage. So there's hyaline cartilage that is particularly relevant in endochondral ossification. When you're talking about endochondral ossification, there's other bones involved that are a part of this, but particularly relevant here is long bones. There's steps in endochondral ossification. What's the first step? that's going to be in this process.
So in the diaphysis, it goes outward.
Before that. So when do we start talking about endochondral ossification? Or for that matter, intramembranous ossification? So give me a more specific date in your life.
4 weeks, 8 weeks.
Embryonic.
Embryonic, okay, so 4 weeks, I think what you meant is 4 weeks after fertilization, right? But 4 weeks, it could be 4 weeks ago, it could be 4 weeks after birth, right? So 4 weeks after fertilization, really, very, very early on in your life, okay? So ossification is starting, but before the ossification has to happen, you need to have a matrix down. You need to have something laid down. And that first matrix is called the hyaline cartilage, right? So there's a matrix that's laid down.
Mister, your pencil is dying.
What?
Your pencil is dying.
Is it?
Yeah.
How do you know
Man,
Cause they gave you the notification.
that? All of that?
is that what that said? Damn.
Yeah, it says Apple Pencil 20%.
So there's first step, then there's the primary ossification center.
Oh, and then the secondary.
Now, where does the primary ossification center happen? In the diaphysis?
Yeah.
When does secondary ossification, well, where does the secondary ossification center happen?
What do you mean, epiphyses?
And how many epiphyses does each long bone have?
There's
There's two. There's the proximal and a distal epiphysis. What type of cartilage are we talking about for secondary ossification? We're talking about hyaline cartilage again, right? Now, hyaline cartilage is going to be ossified, and it goes from the epiphyseal plate to the epiphyseal line. And then there's also hyaline cartilage, and there's also articular cartilage. Articular cartilage is more substantial than hyaline cartilage and is on the epiphyses of each bone, of each of the long bones. And those are going to be preventing the bones from smashing into one another and producing arthritis, right? So secondary ossification, when does secondary ossification end?
like in the 20s.
Well, so not a particular time, but generally after puberty, after the person stops growing. Sometime after puberty. How are intramembranous and endochondral ossification controlled? I'm not sure I'm going to get this whole thing discussed. How are they controlled?
What? What was the control?
How are they controlled?
What is?
Intramembranous and endochondral ossification is controlled by the body. How? What hormones?
The parathyroid hormone.
So there's 3 hormones in particular. There's PTH.
GH.
So there's parathyroid hormone.
Big growth hormone.
No, well, that's a different, right? But specifically to documenting or controlling calcium in the blood, right? And that stuff, right? That's called remodeling, right? So,
Calcitonin. Jinx, knock on wood.
so bone remodeling here, we're talking about calcium in the plasma.
Where is it?
So there's 3 hormones, right? So there's PTH,
Calcitonin and
Oh, calcitrol, right? Calcitrol.
now, where do we get calcitriol from?
vitamin D.
Well, calcitriol is vitamin D.
Oh, from the
Oh, it
sun.
would be from the sun.
The U,
This is
U,
what-
U,
this is
yeah,
from our
UV.
skin.
So there's two sources.
It's on cholesterol.
Yep.
So the skin and UV light is where calcitriol comes from, and also from your diet.
And from the
Right. And then we have PTH and calcitonin, and those two are responsible for negative feedback on the calcium levels in the blood plasma, right?
positive feedback of like
Yeah, calcium trial is the one that, is that the one that lowers the calcium level or increases it?
Wait, calcitonin and PTH or parathyroid hormone. Now, first of all, I'll get to you in a second. First of all, parathyroid hormone is part of the is produced by the parathyroid gland, and then calcitonin is produced by the thyroid gland, both of which are located right around your larynx, right here. Now, PTH is responsible for what? You either elevate or depress blood plasma concentrations of calcium.
I think it's decreasing.
So it's
'Cause It
decreasing.
inhibits the osteoclast activity, right?
It decreases, so it increases blood plasma concentration of calcium. It decreases the amount of calcium in bones. So those two things go together. And if one increases osteoclast activity, then as a result, the blood plasma of calcium increases. The calcium in the bones decreases. So it's a little bit like you having a full tank of gas and you driving a mile down the road. You're not talking about losing a lot of gas, but there is less gas used, right? You have a ton of calcium in your body. So a normal healthy adult, even if you're taking calcium out and putting it into the blood, it's not really gonna affect anything. Until it gets too much of a problem. So decades long, and then it might be a problem. The opposite is true too. Calcitonin depresses the activity, or increases rather the activity of osteoblasts. It doesn't really do much to osteoclasts. It increases the ability of osteoblasts, and so then that increases the amount of calcium in the bones, and it correspondingly decreases the amount of calcium in the blood. That negative feedback, when we're talking about negative feedback, we're worried about blood plasma, calcium plasma, calcium in the blood. Okay. Is there? I don't think there's anything else that we're talking about from this. Well, the other thing is just disorders of the bone, and that in particular, there's arthritis. The last thing is, yes?
Are you gonna put this in Brightspace?
Yes.
Thank you.
Yeah, I'm
Thank you.
definitely. The other thing to talk about is chapter 5, which is the skin, and you guys can do that, right?
Yeah,
All right,
sure.
so I'm gonna let you guys go.